Everyone. So in this video I am going to discuss Appel reaction and its important features. So Appel reaction, as you can see, this is the general scheme. Here we have taken alcohol. So this is the alcohol, and in presence of CX4 where X may be Cl or Bi, so this is basically tetrahalomethane, we are getting this OH group substituted by this halogen. Now it is not just a simple substitution, there is also inversion. Now inversion, that question arises only when this you have two different R groups attached to this carbon, then only this question of inversion arises. But the mechanism is SN2. Now this reaction is used to convert alcohol to an alkyl halide when inversion is required if it is secondary alcohol, and here we are using CX4 and PPH3, triphenyl phosphine. Now here the solvent that we are going to use is non-polar aprotic type of solvent like dichloromethane, toluene, tetrahalomethane. Now why it is so? It is because it is SN2 reaction, so that is why non-polar aprotic solvent must be used. This reaction has some similarity with Mitsunobu reaction, and probably I am going to discuss that reaction in the next video. But what is Mitsunobu reaction? What is the similarity? Just have a look here. Here also this OH group is replaced by nucleophile, though it is not restricted to X. And here there is slight difference in the reagent that we have taken. Okay, so it has similarity. So here this Appel reaction, next we will see what is its mechanism. But remember the main purpose why we are using this PPH3, the reason is we want to convert OH group to a good leaving group, because OH group itself, it is not good leaving group. So if we want substitution, obviously we have to first convert it to good leaving group. That is the purpose of using this phosphorus compound. So look at the mechanism. The first step is activation of this PPH3 by reaction with CX4. And you can also call this step as if it is halogenation of PPH3. So here this phosphorus, it is attacking this halogen, and carbon halogen bond, this bond will be broken, and there will be negative charge generation over this carbon. Now remember here phosphorus is not going to attack over the carbon. It will attack here, because look at the size, and also attacking at this carbon is difficult. It is comparatively easy if it attacks at halogen. So PX bond will be formed and there will be positive charge over phosphorus. So these two are the compounds we are getting here. Now in the next step, this CX3 minus that is generated, negative charge over carbon, it will deprotonate the alcohol, which is our actual substrate, and when this H is removed by attack of this carbanion, there will be generation of O negative, and that is we are calling alkoxide, and here byproduct will be generated, which is halophine. Fine. So CX3 minus attacking this H, now there is negative charge. Now once this negative charge is generated over the alcohol, we are getting alkoxide. The third step will be, now it will attack, that is the attack of alkoxide to phosphorus, and it will generate this type of oxophosphonium intermediate. Okay, so this negative charge, it is attacking here, and this phosphorus halogen bond is broken and there is removal of X minus. Now once this attack is happening, there will be still positive charge over phosphorus, but remember here this type of lone pair donation from oxygen to phosphorus is possible, and OP double bond formation, that is that can happen. So these two types of structure, both probabilities are there. And finally this remember the X minus that is removed in this step, that is the third step, that X minus will attack this carbon, which is already having this OPPH3 group, which is now a good leaving group. OH group is, it is already converted to some good leaving group, right? So this X minus, if it is attacking here, this carbon oxygen bond will be broken and it is attacked from the opposite side. But that question arises only when if it is secondary alcohol. So this is SN2 displacement by this halide anion, and here this will be the byproduct, right? Now this is actually the driving force, because this bond is very strong. The strength of P double bond O is very high, and this is the driving force for this reaction, for this last especially. So now we have obtained our final product, which is this one. Let's have some example of Appel reactions. Though the mechanism that we have just seen, that is the first reported, and after that there is so many works going on. There is some modification over this reaction. So some references we will see here. ROH is converted to RCl, where R may be alkyl or benzyl. Here directly PPH3 is not used. So as I have said, there are several modifications are there as more research is going on. So that is why now PPH3, you can see it is not exactly that compound, but something like that. And instead of the halogen that we have taken, we have just seen the mechanism, it is different, PHCCl3. So one halogen is replaced by PH. One more example we will see. Again ROH is converted to RX. Now this X may be Cl, Br, I, and that depends on what compound we have started with. Here PPH3 as it is, no change. Then the third example, here PPH3 again we have, but instead of tetra, that is all the halogens are not same. As you can see, 1 bromine and 3 chlorine. So 2 types of halogens are there. But all these are examples of Appel reaction. Well, one example we will see where you can call it modified Appel reaction, because in the Appel reaction we have seen we have started with alcohol. But suppose here instead of taking alcohol, if we are starting with RC double bond OH, that is carboxylic acid. And in the medium, we already know how this compound is formed. So that step I am just jumping. So if it is so, now this oxygen lone pair, it can attack and halogen will be removed. So now what we are getting, RC double bond O, and then there is oxygen PPH3. There will be positive charge. Now under this condition, suppose I have taken a compound ethanol amine. So this is ethanol amine. Now this lone pair over nitrogen, it will act as nucleophile, and here this carbon oxygen bond will be broken. So this OPPH3 part is removed, and what we are getting? We are getting RCO NH. Now this one OH is still there, right? Again, one more of this molecule, if we take, then this oxygen, it can react with this phosphorus, same type of reaction. Again I am doing, so this NH, oxygen, PPH3, positive charge. Now finally this attack will take place, it will attack here. So there will be oxygen carbon bond generation, and this part will be removed. So what we are getting? We are getting R, there will be CN double bond. So just put some number, so it will help you to understand the reaction. So it is 1, 2, 3, 4, 5. So here what is happening? This 1 oxygen and 5, these 2 positions are now connected. So we are getting 5-member ring, right? And here the fate of this molecule, that is the other part, is actually first you can write it, there is negative charge over oxygen, so you can write it like this, O negative P plus PPH3, but if you put a double bond here, so both are actually same compound. So in this way we can also get 5-member ring. But suppose instead of taking this nucleophile, if I am taking R2NH or I am taking RNH2, these can also be taken as nucleophile. So in this case what we will get, instead of this molecule, now we will get RCO NR2 or NHR. So what in general we can say that we are getting amide. Similarly, if we take, instead of taking R2NH or RNH2, suppose you are taking ROH, then what we will get? We will get ester. So these are the different modifications of Appel reaction. Here we have taken ethanol amine, and you can see this type of 5-member ring we are getting. You can also take R2NH, RNH2 or ROH, and depending on what we are taking, we will get different types of final product. Now finally, the drawbacks of this reaction: use of toxic halogenating agents, that is obviously the drawback, because that is not very benign, and organophosphorus side product. Now the generation of PH3P double bond O, though that is helping us as a driving force, because this P double bond is very strong, so that is why it is helping as a driving force, but still it is difficult to separate this compound from organic product. Now as research is going on, these organophosphorus side products, sometimes there is some modifications done, so that is PPH3, there is some modification or some derivatives are taken, so that it becomes water soluble, and removal of this compound from the reaction mixture, that will become very easy. So these are the drawbacks of Appel reaction. So that is all about this video. I will come in the next with some new reaction in the next video. Thank you for watching.